Hi everyone, in this video we will talk about the mean median mode or the central tendency measures in case of continuous data. So let's start with the mean. So imagine we have this continuous data with classes. Here we have the salary between 10, 0 and 10, 10 and 20 and so on. Those are our classes. This is the frequencies. So to find the mean, the first thing to do here is to find the midpoint of each class, and we saw this in previous videos. So the midpoint equals the lower boundary of the class plus the upper boundary of the class divided by 2. For example, for this class, the midpoint is 10 plus 20 divided by 2, which is 30 divided by 2, and we get 15. This is the midpoint. We do the same for each class. Once we have this, we calculate the sum of FE times the midpoint. So the midpoint here replace XE in the discrete data. So we find this FE times CE. So the CE here is the midpoint. So 4 times 5, which is 20, 5 times 15, which is 75, and so on. In the end, we get this total, the sum. And XE actually is this sum. XE is this sum divided by the sum of frequencies. So we get 19.5. This is how we calculate the mean in case of continuous data. Now let's see the mode. How to get the mode in continuous data. It is easy to find the model class, but it is a bit complicated to calculate the exact mode, the exact value. So the first thing to do is to identify the model class. So the model class is the class that is with the highest frequency. So let's check here our frequencies. Where is the highest here? It is 9. So the model class is 20 to 30, or we can identify it graphically. It is here. The tallest bar here is this one. So this is the model class. Now let's see how to get a formula that we can use to calculate the exact value of the mode. So graphically we assume that the frequency goes up from 5 to 9 linearly, which means from 5 to 9 linearly, and it goes down from 9 to 2 linearly as well. So we get this. Actually, this means that where there's two lines intersect, so it goes up until here, then it goes down. So where they intersect, this is actually the mode. So we draw a vertical line, and here is the exact value of the mode. This is how to identify the mode graphically. Now let's see how to calculate it with formula. So now, as you can see here, we have two similar triangles. This is the first one, and this is the second one. And the property of similar triangles says that this divided by this, the base, equals this divided by this. So what is this actually? Let's check it here. So this actually is 9 minus 5, and this is the frequency of the model class minus the frequency of the class before the model class. We call it delta 1. And what is this actually? It is this, which is the mode, until here it is the mode, minus this one, which is the lower boundary of the model class. So delta 1 divided by the mode minus the lower boundary equals this. What is this? So this is called delta 2. How we get delta 2? It's 9 minus 2. 9 is the frequency of the model class, minus 2 is the frequency of the class after the model class, divided by this part, or this, yes. So, and how we get this? It is actually h, this minus this, and this actually we know it is the mode minus the lower boundary of the model class, so it is h minus this. And by doing some basic mathematics, we will get this: delta 1 times h equals delta 1 times mode minus lb plus delta 2 times mode minus lb, and we will in the end get this: mode minus lb times delta 1 plus delta 2 equals delta 1 h, and finally we get our formula for the mode in case of continuous data. So mode equals lb, which is the lower boundary of the model class, plus delta 1 divided by delta 1 plus delta 2 times h. Now let's replace all this in our example. So the lower boundary of the model class is 20. Delta 1, which is the frequency of the model class, minus the one before, which is 9 minus 5, we get 4. And delta 2 is 9 minus 2, we get 7. So times h, which is the width of the class, 30 minus 20, which is 10. So the mode is 23.63. So now you know how to get the mode graphically. As I said, you just need to link here the left corner with the right corner, so the left or the right corner of the class before the model class with the right corner of the model class, and the left corner of the model class with the right corner of the next class. Where they intersect, you draw vertical line. This is the mode, or you can calculate it mathematically here with this formula. Mode is the lower boundary of the model class plus delta 1 divided by delta 1 plus delta 2 times h. As I said, delta 1 is the frequency of the model class minus the frequency of the class before, and delta 2 is the frequency of the model class minus the frequency of the next or the class after the model class. So that's it, and see you in the next video. We talk about the median and quantize.